Welcome to Unit 6 entitled Temperature and Heat. In this unit we're going to focus on the section 6.2 entitled Measuring Temperature. Before we look at the section in some detail, it's important for you to know the learning objectives for this particular section. So in this section, students will be able to define what temperature is. They will know the different types of thermometers, and they will understand the applications of thermometers, and they will understand temperature scale. So let's start off by looking at what is a thermometer. So a thermometer is a device that measures temperature or the temperature gradient. And in fact, a thermometer has two very important elements. There is what's called a temperature sensor, which is like the bulb of mercury in a glass thermometer, or the digital sensor in an infrared thermometer. So it's a temperature sensor in which some change occurs with a change in temperature. And so that's the first very important element of a thermometer in terms of having what's called a temperature sensor. And then the second important element is that there has to be some means of converting this change into a numerical value, like the visible scale that is marked on a mercury in glass thermometer, or the digital readout on an infrared model. So thermometers are widely used in technology and industry to monitor processes. And it's also used in meteorology, in medicine, and in scientific research. So here on the right-hand side, you can see that we have a diagram of a thermometer. And you can see that in this particular glass thermometer, we have the bulb. And in this case, the bulb contains mercury. And you can see there's a partial vacuum inside the tube, which allows the mercury to move up unhindered as the temperature changes. Now, as we mentioned, there are different types of thermometers, and we're going to have a look at the various types of thermometers in some detail. So let's start off by looking at the first one, which is a mercury thermometer. Now, mercury thermometers, they work on the basis of thermal expansion of mercury, and the mercury expands with increased temperature. Clinical thermometers and laboratory thermometers, they are made of mercury. And the clinical thermometer is used by health officials in hospitals and in clinics. Now, the laboratory thermometer is used by scientists for research purposes. Now, the second class of thermometer is the alcohol thermometer. And this is used to measure extremely low temperature, and it ranges from minus 80 degrees Celsius to 100 degrees Celsius. Most of the thermometers that you use in your science laboratories tend to range from 0 degrees Celsius to 100 degrees Celsius. Now, there's another type of thermometer called a thermostat. It's made up of a bimetallic strip and a scale. And the bimetallic strip is made up of two different metals which are bonded or glued together. Now, because the metals expand at different rates, the combined strip bends in a certain direction when it's heated. And when it cools, it bends in the opposite direction. So we use thermostats in refrigerators as a switch. And then the next type of thermometer is the electronic thermometer, which works in an entirely different way to mechanical thermometers. Remember that mechanical thermometers, they use mercury or spinning points. But in the case of electronic thermometers, they are based on the idea that the resistance of a piece of metal changes as the temperature changes. So in other words, as the metal gets hotter, then the atoms inside that metal, they vibrate more inside of the metal. And so it's harder for electricity to flow. And that's because the resistance increases. And so similarly, in metals that cool down, the electrons move more freely and the resistance goes down. So an electronic thermometer works by putting a voltage across a metal probe and measuring how much current flows through it. And then inside of that electronic thermometer, you have a microchip, and that microchip measures the resistance and converts that resistance into a measurement of temperature. And so the main advantage of thermometers like this is that they can give you an instant reading in any temperature scale that you like, Celsius or Fahrenheit, or whatever the temperature scale happens to be. But one of the disadvantages of electronic thermometers is that they measure the temperature from moment to moment. So the numbers they show can fluctuate quite dramatically, sometimes making it very difficult to obtain accurate readings. In the diagram here, you can see that we have each of those 4 different types of thermometer. Here we have the alcohol thermometer, which is the one that you use a lot in schools. Here we have the mercury thermometer, which is used in sort of clinical environments, hospital environments. Then we have the thermostat, which involves a bimetallic strip, which is used in refrigeration, for example. And then we have the digital thermometer. What are the applications of thermometers? Well, thermometers are required for numerous purposes, and these range from the household use to use in the industrial sector. Now, in the kitchen, the temperature of food can be measured using thermometers. And likewise, in the refrigerator, we can use thermometers to maintain a set temperature in the refrigerator. In the factory, for example, the thermometer in the furnace will enable turning on and turning off of the furnace. So it's very important to choose the right type of thermometer which suits the intended application in terms of what you want to use it for. So in other words, it would be pointless to use, say, a factory thermometer in a furnace in order to measure the temperature of food, because these furnace thermometer is probably calibrated for very high temperature measurements, and so probably wouldn't be very suitable for use, for example, in the kitchen. Let's have a look at some checkpoint questions related to what we've explored so far. So how can you measure accurately the temperature of a body? And the second checkpoint question is, describe the different types of thermometers. And the third checkpoint question is, explain how a mercury thermometer functions. So draw a diagram of a thermometer and label it. So have a go at these checkpoint questions. I'll give you a few moments to go through them, and then pause the video. When you're ready to compare your answer with that of the answer provided in the solution, then press the play button. Let's have a look at the first checkpoint question. How can you measure accurately the temperature of a body? And you do that using a thermometer. So that's quite a simple question in terms of just knowing that you can measure temperature of anything, of any body or any substance, using a thermometer. So the second checkpoint question is, describe the different types of thermometers. Well, we have, for example, mercury thermometers, and we also have, for example, alcohol thermometers. So those would be two of the more familiar thermometers that you would probably use in your school or even at home, or even possibly in, for example, a medical setting, a clinical hospital environment. The final checkpoint question here was explain how a mercury thermometer functions and then draw a diagram of the thermometer and label it. Well, a mercury thermometer operates by contraction and expansion of the mercury or the alcohol in the bowl. So as the temperature increases, what happens is that the mercury or alcohol in the bowl will begin to expand. And so what you'll see in terms of the thermometer is that the liquid appears to be expanding and moving as the temperature increases. And similarly, in terms of when the temperature begins to decrease, then you will see contraction. In other words, the liquid in the thermometer, whether it's mercury or the alcohol, will literally seem to be decreasing in terms of its length due to contraction.